Welcome back to the second video of this pattern recognition lecture series. So on the first video, that was the introductory video of pattern recognition, where we have talked about what is pattern recognition, what are the applications of pattern recognition, then what are the different types of learning techniques such as supervised and unsupervised, also the what is called feature and how to recognize these features using the pattern recognition design cycle. Those were there in the first video. Today we'll be moving into our first algorithm in the pattern recognition, that is the Bayesian decision theory. By this particular algorithm we can recognize patterns. So this particular lecture video has been inspired from this book. You can follow this book for this particular chapter, as well as different concepts from different slides have been taken from the Google search as well. That is, some images or something like that, those have been taken from the Google search, and the theoretical part has been taken from this particular book. So these are the two references. So just let us give us a very brief introduction or overview of this particular algorithm. Bayesian decision theory is a fundamental statistical approach to the problem of pattern classification. It quantifies the trade-offs between various classifications using probability and the cost that accompanies such classification. For this particular theory, we have two assumptions. First one is decision problem is posed in probabilistic terms, and the second assumption is that all relevant probability values are known. So let us start this particular decision theory in the concept or in the problem where we are going to classify fishes. Suppose we have two different types of fish, one is salmon, another is sea bass. These two fish we want to classify. So it's a two class problem, as there are two different classes there. And the difference between classification and clustering has already been taught in the first lecture video. If you don't know about that concept, please go and refer to that particular video in this pattern recognition lecture series itself. So in this salmon and sea bass, that is two fishes are there, and this fish classification problem that we are going to solve using this Bayesian decision theory. So let us assume that any given fish is either a salmon or a sea bass. So there can be only two different fish, and this is that called this the state of nature of the fish. So that is simple like that. In the class, what is the class of the fish? The class of the fish can be any two between these two, and that is called the state of nature of the fish. And now let us define a probabilistic variable W, where W equal to W1 for sea bass and W equal to W2 for salmon. In this decision theory, there are certain concepts are there. First concept is prior probability. The a priori or prior probability reflects our knowledge of how likely we expect a certain state of nature before we can actually observe said state of nature. That is, this particular probability is going to show our knowledge. That is how we are expecting a certain class of fish before that is actually that certain fish of class of fish has came in front of our eyes. That is, before observing that, how we can expect that particular state of nature of that fish. In the fish example, it is the probability that we will see either a salmon or a sea bass next on the conveyor belt. So next on the conveyor belt, what we can expect? That was the probability. The priors may vary depending on the situation. If we get equal numbers of salmon and sea bass in a catch, then the priors are equal or uniform. So that is, equal number of fishes for each of the class is same. So that is, priors will be equal. And depending on the season, we may get more salmon than sea bass, for example. Then the priors will be different. So here, how to represent this prior? That is probability of W equal to W1, or just simply we can write probability of W1. For the prior, the next is a sea bass. The priors must exhibit exclusivity and exhaustivity. What is that? That is, if one fish belongs to one particular class, it cannot belong to the another particular class. That is the thing, that is exclusivity and exhaustivity. For C states of nature or classes, suppose we have C number of classes. For the fish classification problem, what could be the value of C? C value can be 2. But suppose C value can be more than 2 as well. Then what happens? The summation of all the class probability values would be 1. Right? That is summation of Ci equal to 1 to C. Probability of Wi. That is, I can be any value between 1 to C, and the probability summation of all the classes, that is Wi, that will be 1. That was the concept. Now, how we can decide, or what is the decision rule from only priors? That is, we have only prior probability. How we can decide based on that? Our decision rule prescribes what action to take based on observed input. That is, we have some observed input. Based on that, decision rule is going to prescribe what action to take. Now, what could be that? That is the decide W1 if probability of W1 greater than probability of W2. Otherwise, decide W2. That is, the class will be decided based on whether each prior probability is greater than the other class prior probability or not. If the priors are uniform, then this rule will behave poorly. Why? Then probability of W1 equal to probability of W2. Then this rule is falsifies, as this equal or greater than sign is not there. There is an equal sign. So then this particular rule will behave poorly. Now, in this particular pattern, we have in the last class we have talked about features. Let us again recapitulate this features thing in correspondence with this fish classification problem. A feature is an observable variable. A feature space is a set from where we can sample or observe values. For this particular fish classification problem, what could be the examples of features? Length, width, lightness, that could be the features of one fish by which one particular fish can be distinguished from the another class of fish. Those are the features. Now, in the next class, we'll go into the much deeper and we'll talk about other concepts that are present in this Bayesian theory. So, this much for today. Thank you everyone for watching this particular video, and happy studying.